Hi everyone. Today we are going to do the fourth part of acid, base, and salts. So last class, like I wrote five salts, but uh, I make a video only till third salt, right? So today we are going to do remaining two salt and one more topic we are going to cover in this class. Uh, Today is going to be the last class for theoretical thing. One video I'll make whatever the important questions are there in this chapter, so that we'll make. Let's see like what is remaining in this chapter, more theoretical. Yes. So we can say washing soda, right? Washing soda, if you will see here, it is remaining for us, right? Yes. Washing soda is what? Sodium carbonate. By the name itself, we can say it is used what? To cleaning clothes and all, right? Anything washing related, that is what? Washing soda. Chemical formula is what? Na2CO3 dot what? 10H2O. Na2CO3 dot 10H2O. So sodium carbonate, sodium hydrogen carbonate on heating. Sodium hydrogen carbonate means NaHCO3, right? NaHCO3 on heating decomposes to give sodium carbonate. Sodium carbonate plus actually water and carbon dioxide will come out, right? On recrystallization of sodium carbonate produces what? Washing soda. So Na2CO3 is the sodium carbonate, right? So that if you will recrystallize, means if you will heat it with the presence of water, then what will happen? It will gain water and 10 molecule of H2O it will take. It will become what? Washing soda, right? 10 water molecule is there. So that we'll discuss later why 10 water molecule came here. What is the use of that 10 water molecule? That we'll see further. Fine. Uses is what? Used in glass, soap, and paper industry. Employed in the manufacture of sodium compounds such as borax, right? Borax now we are not supposed to know, it is not used that much, so we will not learn completely what is that. But you can remember that what it is used in what? Borax. Used to remove permanent hardness of what? Water. Obviously, if you will, if water is hard, right, then we cannot use soap and all, right? So we'll have to put that also is removed by what? Soap only, this washing soda, right? So this is Na2CO3 dot what? 10 water molecule. Fine. The next compound, if you will see, that we are going to see is plaster of Paris. Plaster of Paris, if you are going to see, is what? Calcium hemihydrate. What is this? Calcium hemihydrate. Hemi means what? Half. Right? Plaster of Paris is prepared by heating of gypsum, that we'll see. On heating it, it loses water molecules and become calcium sulfate hemihydrate, right? On heating it, it loses water molecules and becomes water molecules, right? And becomes what? Calcium sulfate hemihydrate, which is plaster of what? Paris. Okay. If you'll see how it works is CaSO4 and then what? H2O CaSO4, right? So this both shares this water molecule half, so hemihydrate, right? So calcium, that's why we wrote here 2H2O. If you will take half of it shares, so it becomes what? Half CaSO4 dot half H2O. So CaSO4 on 100 degrees Celsius, if you will heat it, it will give you CaSO4 dot half H2O plus what? 1 by 2 half H2O, right? Uses, if you will see, statues, right? Statues we can say, and fall ceiling, right? Fracture whenever hand and all breaks, right? So that we use what? This POP only, right? Second, next what we can say, the main property of POP is what? If you put little water, if you mix water on that, it is going to be what? Hard. So we are using these things: statue, fall ceiling, and fracture. In fracture we are using. Okay, now as I told before that what? There is water molecule 10H2O, here also half H2O. What is the use? Why? Actually what happens, no, if you will mix water, then what will happen, that we are going to see now. Okay, so water, if you will see, then we can say solid, if you will see, two types of solids are there. One is amorphous and crystalline. The shape of amorphous I haven't drawn, but anyway, any shape is amorphous, right? It should not be exactly the triangle, but fine, like this kind of, right, amobia kind of thing you can draw here, right? Okay, anything amorphous solid, right? Amorphous solid means what? Irregular patterns of ion molecule atoms in a solid, right? That is known as what? Amorphous. What is crystalline is what? It is having a regular pattern, right? Cube and then one and then one. So it becomes strong. It becomes what? Strong. Here bonds, if you see one bond and then one bond and then one bond, it is like this, arranging like themselves like this. Crystalline is like this. 1, 2, 3. See, 3 bonds are there, right? So it is it will arrange like this. But crystalline is not like that. It will make like a shape of a square, cube, sometimes sphere, so that can easily break, right? So that is amorphous. Amorphous example, glass. Crystalline is what? Regular pattern of ions, molecules or atoms in a solid. Example, diamond, sodium chloride. These things are what? This crystalline solid, right? So crystalline solid we'll learn in more detail. Now what happens actually when you will put water molecule? Let's see. Crystalline solid, if you will see, two types of crystalline solids are there. First is what? By nature, and one is what? If you'll add water molecule, then it become crystal. Let's see. First, water by nature is what? Diamond, obviously by nature. And then what? Sodium chloride by nature. NaHCO3, that is also by nature. But when you are adding water molecule, Na2CO3 dot 10 H2O, right? And then what? This CSO4 dot half H2O. These are what? These elements, these compounds, if you add water on that, it becomes what? Crystalline. It becomes what? Crystalline. It means what? Whenever you will add water molecule on any element, that becomes what? Crystalline, right? So we can say regular pattern of ions, molecules or atoms in solid. That is two types of crystalline is there. One is what? By nature. One is what? Adding water on that. Fine. So let's see next. If you will see what happens, irregular shape is there. That if you will put water on that, like if you will put here what? Water, then what will happen? It will become in a regular shape, right? Regular shape means these types of shapes will form. It is a form kind of what? Crystal. That is what it is representing, is what? It's form like a crystal, right? Many salts contains what? We can say many salts contain water molecules and are known as what? Hydrated salts, right? The water molecules present in salt is known as what? Water of crystal, right? Water of crystal. It means what? Whenever water is there, so water of crystal. The water of crystallization is fixed number of water of crystallization means what? Adding fixed number of water molecule. Adding what? Fixed number of water molecule. It helps to what? For making the any compound to what? Crystallize, right? If you'll add in any amorphous, so fixed amount of water molecule, if you'll add, then it will become what? Crystalline salt, right? Like the element, the solid will become what? Crystallize. See, amorphous and crystalline. So that becomes what? Crystalline. So we can say there are a few examples where we put water molecule, we add fixed amount of water molecule, that becomes what? Crystalline solid. That is gypsum, CSO4 dot 2 H2O, green vitriol, FeSO4 dot 7 H2O, blue vitriol gives what? CSO4 dot 5 H2O. So these are the examples of what? By adding water molecule, you will get crystalline solid, it will become. So till here we can say we finished everything in this chapter. From all the dots we finished of this chapter. What I'll do is one lecture around 20 minutes. I'll take few questions that I'll answer, right? We will discuss there. I'll put a worksheet for this chapter so that you guys can solve. So finish. Now almost everything we finished, not almost everything we finished. So now you guys can read book. Obviously you'll have to read books and theories and all. You can, whatever I wrote, that is enough for this chapter. Till here you guys revise. We'll meet again in the next class.